You've written some papers on this, on DSO, distribution system operator. Can you talk a little bit about what that concept is and how it's relevant to the challenges that we're looking at on the system? And then we can dive a little bit into, sort of who in Texas is a DSO. But first, what is it?
Yeah, so the DSO is the idea of having a version of the system operator that applies at the distribution level. So, there's a few different models for what that could look like, but most typically we'd be talking about like the distribution utility taking on something more like a system operator role and probably optimizing locally for services within that grid while also acting as part of a larger system is kind of the most typical version of that. You asked about definitions of orchestration. And so, if the idea is to be able to have controls over supply on the one hand and demand on the other, and to be able to flex both of those intelligently against each other in real time and over time, which is the actual definition I'd give you of orchestration. You need an orchestrator, like something that can actually take an intelligent view of those system needs, and that needs to extend all the way into the distribution side because that's where the demand is mostly connected. So if we think about what would it take to actually be able to flex demand in that broader system operator model, you got to go to where the demand is, and that is in the distribution grid for the most part.
Yeah, it's interesting when I bring this up in like tweets or LinkedIn posts, I inevitably get some kind of reply that is along the lines of all this DER kind of stuff is just so complicated. We just need to build enough, dispatchable generation and just have that meet load. Two problems with that. One, just as you were describing with Google, like when they were trying to do this for data center capacity, it is very, very expensive. And even for an entity like
Tremendously.
Google, right? Even for an entity like Google, making a lot of money, obviously, like not terribly starved for cash. Like nobody wants to just waste money. That's not right. Like we are supposed to be using our economy. We're supposed to have an efficient economy because that creates wealth, right? So A, it's wasteful and inefficient. B, it is also in many important ways not as reliable and resilient because, again, you have more of kind of the single points of failure, which is one of the things like we saw during Winter Storm Uri is like a major problem on the gas system, gas plants freezing up, wind turbines freezing, like these big generators and big systems failing. If you had had more edge systems that could have continued to operate, particularly, and I think kind of in this in some of the maybe not first wave, we're probably already into a first or second or third wave, whatever, but in some of the early stages, making sure critical infrastructure, your hospitals, your police stations, your, communications facilities and water treatment facilities all have those kinds of generating assets also makes the system more reliable and more resilient. But it is challenging, right? Because then you used to have a system where you kind of knew here's where that generation's coming from. I could maybe not count on my hands, but like, there's like a 100 or 200 points and like I know where they are and they're telemetered and I know what's going on at them. And now you're talking about this world where there's millions. So we don't want to minimize the challenge, but if we do it right, if we get that orchestration piece right, we can have a lower cost, higher reliability system. Correct?
Absolutely.